Okay. As I was saying, on our last video, as I was explaining why we don't need to write the direction for FT, it was because the question, we were asked to calculate the tension in the string connecting the two blocks, which means there is tension, this force. Calculate tension in the string connecting the two blocks. It means like we're only required to like find the magnitude, not really the direction. If maybe they asked to like to calculate the tension acting on our 4 kg block, that's when maybe was gonna like write the direction. Or maybe sometimes like it depends on the direction we choose as positive and negatives. So sometimes you might calculate your tension and then you find that the value it has a negative value, it's a negative answer, so that's your direction. That negative sign there is your direction. But sometimes you don't need to write that negative value. You can write that negative value and then you say therefore tension is equals to 47 newtons to the right or to the left, or one, just like that. So okay, let's go on our second question. Two blocks of masses 5 kg and 2 kg are connected by a light inextensible string. A force, which is F, is applied on 5 kg block at an angle of 20 degrees to the horizontal, and the system of blocks accelerates to the right at 2 meters per second square. Kinetic frictional force on the 5 kg block is 10 newtons. Okay, we're given the kinetic force, we're also given we're given the kinetic frictional force, and the acceleration is given there, and the angle of inclination, which is 20 degrees there, and the force applied, which is F, and then we're given the masses, which is 5 kg and 2 kg block. Okay, and it is said light inextensible string. Light inextensible string, it basically means same acceleration and same tension. Same acceleration, it means the acceleration that you're going to calculate, that you're going to find on both. Or maybe, okay, let me say, okay, you have your maybe 2 kg block. Calculate the acceleration that you're going to calculate and find on your 2 kg block. It is going to be the same acceleration that you're going to find on your 5 kg block, which means the acceleration on your 2 kg block is the same as the acceleration on your 5 kg block. And then and that's the tension as well. The tension that you're going to find on your 2 kg block will be the same as the tension that you're going to find on your 5 kg block. So yes, that's what it means, like light inextensible string. Just when I just know that when you come across the statement with light inextensible string, just know the first thing that should come to your head: same acceleration, same tension. You know what I mean? So okay, yeah, just always know that. So okay, we have your diagram here. You can see you have your 2 kg block. Your 2 kg block is not on the surface. It's hanging somewhere there. It's dangling yana there. You know what I mean? Like it's hanging. It's not on a surface. It's just hanging somewhere there via the string, this light inextensible string. It means okay, same acceleration, same tension. Yeah, okay. So then we have our 5 kg block on our horizontal plane. So okay, as we were on the inclination part, like on our first question, the inclination was happening on our surface. It was happening on our plane. So now the inclination is happening on our force applied. You know what I mean? Which is F, force applied at 20 degrees. Okay. So okay, let's go. And don't forget, guys, when you look at my videos, just pause the video and draw this diagram, and maybe the whole statements and the diagrams, so that you can follow me up, so that you don't get lost in the process. Because Now I'm taking a video. I've already done this with the other students. So okay. Okay, it's normal force. Normal force, okay. Normal force, okay, is a definition of a normal force, okay. Is a force or a component of a force which a surface exerts on an object in contact with it, and which is perpendicular to the surface. You hear me? You hear me? You hear me? It's a force or a component of a force which a surface exerts on an object in contact with it. So it means that the normal forces, it will appear when the two materials are in contact with one another, more especially the surface and an object that is placed on the surface. So in contact with it, you can see vele. It means that there should be like a contact force between the two object and stuff. And then the normal force is perpendicular to the surface. Always remember that the normal force is perpendicular to the surface. Like it doesn't matter. It doesn't matter if the surface is inclined or on a horizontal. The normal force will always be perpendicular to the surface, because it is the surface that exerts that normal force, that force on our object. So if it means let's go. If our surface, okay, let's say, okay, it's our surface. Excuse, excuse. Yeah, okay, Mara. Okay, here's our object. It is means that the normal force will be perpendicular to the what? To the surface. Perpendicular to the surface. So if it is on our horizontal, it means our normal force will be perpendicular to our surface. One perpendicular. So okay, we are here now. We are here now. Hey, excuse. We are here now. So okay. It was required that we draw the free body diagram of all forces acting on the 5 kg block. Okay, here's our 5 kg block. Don't forget, remember the normal force applied, and here we don't include the components. Don't forget that when we are required to draw free body diagrams, don't include the components. We're not include the forces that are already given, the forces that are acting on that object. So okay, we have a force applied, and also remember we have the normal force. The normal force is exerted by our surface on our object, so it will always be perpendicular to the surface. I mean our normal force. So okay, our gravitational force, it is always acting downwards. Don't forget that it is always acting downwards. It doesn't change the direction. It always acts downwards. The gravitational force. So okay, we have the kinetic frictional force. Always read your statements, and then the statements they have everything that you need. They have everything that you need, and your diagrams, they have everything that you need. When I just read and understand the questions, you know what I mean. There are key points that you need to understand here: the inclinations, the horizontal forces, the vertical forces, the components forces, like those forces that about the accelerations and stuff, the kinetic frictional forces, whatever those forces, need to understand. Now the questions, when they come with these statements, when they say where they say the questions that comes with these statements, where they say light inextensible strain, frictionals, pulling, constant velocity. When it's constant velocity, it means that the acceleration will be zero. Inextensible strain, the acceleration is the same for all the combined blocks, and the tension is also the same. You know what I mean. The only difference that will be a direction. The only difference when they say what is the tension on our 4 kg block is either to the right or left. On our 8 kg block, it's either to the right or left. Things such as that. But the magnitude, the value, the size will be the same. So okay, As I've said, our 5 kg block is on a horizontal, so okay, it means we have, okay guys, hey, don't throw this one because now I drew the components, or one I drew the components. These ones with components, you only draw them when you want to deal with the calculations, but they said draw the free body diagram showing all forces acting on our 4 or 5 kg block. It means why not just always look for those all forces, for all the first 5 forces that you know without the components. You know what I mean? We have our normal force. Our normal force is always perpendicular to the surface, and our force applied. Our force applied was on our inclined, 20 degrees incline. Or so when I don't write about 20 degrees in our these components forces, you don't write them on your free body diagram. You don't include them. When I just write the force applied on that direction that it's inclined at, or when I just show good to know our force applied, it is acting in this direction. You don't draw the components. You only draw them when you want to deal with equations. So okay, normal force is always perpendicular to the surface, and the force of gravity, the gravitational force, is always acting downwards. It doesn't change the direction. So then you have your ft. Your ft is acting on our is directed towards our, you can see the arrow, it is directed towards our 2 kg block. This is our, I got it, this is our 5 kg block. This is a free body diagram on our 5 kg block. So our ft, okay, this system is pulled to the right, or one, because our force applied is to the right, or one, is to the right. So it means, and you can see this is our 5 kg, and okay, let me come here. This is our 5 kg and this is our 2 kg block here, and the system is pulled to the right, one, but on our incline, with our inclined force, one. So okay, 5 kg is bigger than 2, so it means 2 kg is pulled upward, or one, is now pulled upward. So the tension is acting either way, like on our 5 kg block and on our 2 kg block, but what matters now is the direction. So as I've explained before, 5 kg block is exerting a force on our 2 kg block, which is what? Tension. The tension, or one, just as I've drawn here. So the tension will act where? Towards our 2 kg block, because our 2 kg block is the one that is being pulled. 5 kg is exerting, like that rope from our, I get, is connected to our 5 kg. So it means the force, the tensional force that our 5 kg block will exert will be towards our 2 kg block, or one, it will be our 2 kg block. So I get a value, the overall direction is to the right, it's to the right. And don't forget, we have the kinetic frictional force. It was given in our statement. The kinetic frictional force on our 5 kg block is 10 newtons, and the acceleration is given to, which is 2. It's okay. We have our force applied, which is our force number 1. I said don't draw the components, and then don't draw this angle as well. Don't put this angle as well on your free body diagram. You only use this when you want to deal with the calculations. So okay, when you deal with the free body diagram, you have your normal force as well, and then you have your ft, which is acting to the left, and your kinetic friction, which is acting to the left, because the direction is to the right. So your frictional force will oppose the motion to the left. So as I've said, The gravitational force is always acting downwards. It doesn't change directions, this one. So okay, let's go to our questions. They are saying calculate tension. So they are saying calculate tension now. They are saying calculate tension. Okay. So okay, now okay, again we have two blocks, which is 2 kg and 5 kg. So when you deal with the questions, as I've said before, draw your free body diagrams on your rough sketch. Like, don't draw them when you are doing the calculations, like on your answer sheets and stuff. Like, just draw them on your rough sketches, or maybe at the back of the answer sheet, like at the back of the answer sheet, like with a pencil, so that you can like erase later on after one. So okay, or maybe at the back of your answer sheet, just write rough sketch somewhere there, and then do your rough sketches there, you want all. So okay, let's calculate the tension now. Okay, we have our 5 kg block and our 2 kg block drawn on our rough sketches now, ne? Yeah, like, yes, like on our rough sketches. Don't mind the numberings, yeah, just listen to what I'm saying. Don't mind the numberings, yeah. So okay, on our 5 kg block, okay, yeah, we don't have ft value, but and also we don't have force applied. Don't forget, we don't have force applied. We don't have the value of fa. So okay, we don't have the value of fa. So okay, on our 5 kg block, when you draw the freeboard diagram on a rough sketch, so now you can include the 20 degrees, you can include the components for fa, for force applied. So our fx, let me say fxa ne, is acting, is going to the right, where our force applied is going to, and our fy, which it will go upward. It follows the direction of our fa, so they meet somewhere there, or they meet here. So okay, so okay, yeah, we was gonna use the 5 kg block, but because we don't have the f applied on our horizontal surface, so we don't know fxa, so we don't know the forces that are acting on our, I mean, like, we don't have fxa, which is on our horizontal plane, eh? So again, we don't have fxa, and we have 2 kg block. Don't forget, we have the 2 kg block. Always, when you encounter such, like when you come across these types of questions, there will always be that block where you'll find the simple ways to like tackle the question, like find the question fast, find the answer fast. So okay, don't forget, ft value, we don't have him, we don't know him, we don't know the value of him, it will always be ft now. So if it fxa, we don't have him, so it will give us problems later on. It is so complicated, so okay, we have the 2 kg block. So on the 2 kg block, and remember, same tension, same acceleration, like, and here we are required to calculate the tension. So it means the tension on our 2 kg block is the same as the tension on our 5 kg block. So let's come to our 2 kg block. It's the simplest one. So on our 2 kg block, and let's not forget that our 2 kg block is hanging, which means the only forces that are going to act here is the force, the tensional force, because of the rope, and the force of gravity. The force of gravity is acting down. It is acting downward. always acting downward. So okay, let's draw our free body diagram on our 2 kg block. We have the tension Ft, we have the Fg acting downward. So okay, here's our formula, which is Fnet, which is equal to Ma. Fnet, I said, is the sum of forces either on our horizontal or on our vertical direction. So okay, now we are now we're dealing with our vertical forces. Again, we're dealing with our vertical force now. Our tension is on our vertical force on our 2 kg block, but it is on our horizontal on our 5 kg block. So it means on our 2 kg block now that we have only two forces that are acting on one another, that are acting. So okay, we have T, which is acting upward, because it is also trying to pull the 5 kg down, the 5 kg block down. So it will exert a tensional force on our 5 kg block. So our tension is acting where? Upward. You know what I mean? On our 2 kg block. From our 2 kg block, let me put it that way. Yes. So okay, let's go to our Fnet, our formula. Fnet is equal to Ma. So choose a direction you wanna take as positive. So I always tell the students to like use the direction in which the system is taking as positive. So I get a 2 kg block is being pulled upward. So we'll take all the forces that are going up as positive, and all the forces that are going down, that are opposing the motion, as negative. So we have Ft, which is our tension. Our tensional force is acting upward, so it's a positive. So only remember this sign, I only use it because it's only for some, like you only use it before you substitute the values on it on top. Yes, and then before you substitute the values on it, it's okay. Our Fg value is acting downward, but the plus just represent the sum, so I'm just adding Ft plus Fg. We're not talking about the directions now, we're not on the directions now. So okay, let's go. Our second step on our formula is Ft is positive, acting upward, so then it will be negative. Fg, I can say Fg, I said Fg, it has its own formula. Fg is equal to mg, which is m is the mass of that object, and g is always 9.8 meters per square second, the second squared. So okay, our Fg, so okay, we know our Fg is acting where? Downward. It's acting downward, so it's negative. It's minus now. It's minus now because it's acting downward. So our mg just is the formula of Fg, because we want to substitute the values into this one so that we can find the value, the overall value of our Fg. So okay, Ft minus, in place of m we say 2, because we are working on our 2 kg block. In place of g is 9.8, is equals to 2 represent our mass. It's our mass. So then, because we're working on our 2 kg blocks, and then a, it was given a don't forget a, don't forget a. Okay, I get it. A force F is applied on 5 kg block at an angle of 20 degrees to the horizontal, and the system of blocks accelerates. We are given acceleration, accelerates to the right at 2. Like even the direction, it is already given to the right. You know what I mean? So at 2 meters per second squared, it is given. So which means the acceleration is applied on all the blocks, because it's a system now. So acceleration is the same. So okay, you, in place of a, you put 2. So okay, your Ft is equals to, so vele you'll multiply 2 multiplied by 9.8, and then you'll just say you'll transpose to the answer that you're going to find here, and then add it to 4, because this is 2 multiplied by 2 will be 4, and then you take this one, you jump, it's 2 plus the answer that you're going to find here, it will jump to this side, and then our tensional force is equals to 23.60 newtons way upwards, because we're working on our 2 kg block now. So this direction is upward, our upward is positive, you know what I mean? So it means the frictional the tension force acting on our 5 kg block will be negative, or maybe you can just say 23.60 newtons downwards on our 5 kg block. But then we're asked to calculate the tension. The tension. If they say the tension, just the tension connecting the two blocks, when I just leave it with their value. But if they say on our 2 kg block, the tension on our 2 kg block, yeah, you will write the direction like upward, and then on our 5 kg block, you'll say maybe to the left, because that's where it is going. So okay, let's go to our second question. They're saying calculate F, the force applied. I get a value on our 5 kg block. Remember that we don't know our force applied, ne? And we already drew the components. Don't forget the components that you drew on your rough sketches. Don't forget. So okay, our FA applied is on an incline. You can see that angle there is 20 degrees, ne? So it means here we'll have to find the components that are going to follow the principle of either perpendicular to the surface or parallel to the surface. That principle, because we need to use the forces that are following the principle of either perpendicular to the surface or parallel to the surface. So our FA, here's our FA name. So the components, we are looking for the X and Y forces that made FA, basically the forces that made FA, but they are acting on our perpendicular or parallel direction. So on our parallel direction, our parallel our parallel is F X, parallel and XY direction are the same thing. So then vertical direction and Y direction are the same thing. The perpendicular direction, are the same thing. Okay, so okay, we have FA, force applied, so then we have its X component, which is FXA. I don't leave the X because I want you to see that this component is on our X direction. It's on our X direction. Then on our vertical direction, it is FYA. I don't leave Y because I want you to see that the direction that this force is taking, it is on our vertical direction. It is perpendicular. Y and perpendicular, same WhatsApp group. X and parallel, same WhatsApp group. You feel me? So here they're saying they want F, force applied. So okay, hey, this formula, bruh, like this formula, fan, is your key to success on Newton's second law. And understanding it will help you, bruh. Understanding the direction of forces, it will help you as well. And also finding the components, it will also help you, man, to like tackle these questions, like finding the components, because I gotta want to follow the principle of either perpendicular or parallel to the surface. So okay, they want force applied. They want us to find force applied, and force applied is on our 5 kg block. Don't forget that 5 kg block, on our 5 kg block. So okay, they want us to find F. We use this formula. Okay, F net, the sum of forces acting on our horizontal. I get it. F net, F net, we're going to look here. We use the forces that are following the principle of either perpendicular to the surface or parallel to the surface. So we use this the forces that are, so here we'll calculate using, let's first use our horizontal forces. If we don't find our answer here, we'll then use our vertical forces to help us find certain values and answers. Or one, like our newtons, I mean like our normal force. When we want to calculate the frictional forces, you'll need to like have the normal force. So that's when you will use the forces that are acting on our vertical direction, because the normal force is on our vertical direction. So now we want F, force applied, but we know the components of our force applied. We have Fxa and Fx and Fya. Fxa, Fya. So okay, let's start looking at our forces on our horizontal plane, which now we have Ft, Fk, and Fxa, which is the component of our Fa. So okay, let's go back to our trigonometric ratios from mathematics. So okay, we have cos. Okay, we already have the angle, which is 20 degrees, which is equal to our cos. You know the trigonometric ratios from mathematics. Cos is always the adjacent, which will be Fxa. It is adjacent to our hypotenuse, which is Fa. This force, it is opposite. This is our hypotenuse, and this is our adjacent, and this is our opposite force. So Fxa, it is adjacent to our hypotenuse, and then Fya, it is opposite to our hypotenuse. It is opposite also to our angle. This one is adjacent to our angle also. So okay, cos 20 is adjacent over hypotenuse. So our adjacent here is Fxa, which is Fxa here on our diagram, and over our hypotenuse. Our hypotenuse is Fa, which is our force applied, the bigger force. So okay, we can do a cross multiplication because we want to find the formula for Fxa. So as we cross multiply, it will be Fa, because it is Fa multiplied by cos 20. It will be Fa cos 20 degrees, which is equal to 1 multiplied by Fxa, which is Fxa. So we already have the formula for Fxa. And then you can also find the formula for Fya. Fya is the opposite. You know that it is sine 20, which is equal to opposite. Our opposite is Fya over our hypotenuse, which is Fa. Do you get me? So and then we'll do the cross multiplication now, because we want the formula for Fya. So Fa multiplied by sine 20 is Fa sine 20 degrees, which is equal to 1 multiplied by Fya. It is always Fya. It is always that value or that number, that variable. So okay, don't forget, we have the formula for Fxa and we have the formula for Fya. But now we are dealing with the horizontal forces, which means we'll only look at our horizontal force component, which is Fxa now. So okay, let's go to our formula Fnet. So okay, always take the direction in which the system is taking as positive. So okay, our direction, the statement read as it is accelerating where? To the right at 2 meters per square second, which means to the right we're going to use that direction as positive. So okay, let's go on our free body diagram on our 5 kg block. Our Fxa is acting where? To the right now. It is following the direction in which our force applied it is going to. So okay, it is going where? To the right now. So which means it will be positive and the rest of the forces that are opposing the motion, they will be negative. So okay, let's go to our fxa. Our fxa plus ft plus fk, because these are the only forces that are acting on our horizontal plane or one. So these pluses are just the sum. It's the sum of they represent the F net. It's the sum of the forces. So which is equals to ma. So xa, don't forget, we have the formula fxa. We have the formula which is fa cos 2, and remember this fa is our force applied and we are looking for him. So okay, in place of fxa we'll place f, let me say maybe, okay, let me just put a fa cos 20 minus, okay, it's positive, it is going to the right, it is following the direction of our system. So it is fa cos 20. So then the rest of the forces that are opposing the motion, they are negatives. So ft, we already calculated ft, the tensional force, it is 23.60 newtons. So okay, this guy is going opposite to our direction, so is negative. So it will be negative 23.60. So fk, kinetic frictional force, don't forget that it is given, guys. Don't forget the kinetic frictional force on the 5 kg block is 10 newtons. It's 10 newtons. So okay, don't forget that. So it is given, but it is opposing our motion. You know, always the kinetic frictional force, the frictional forces, they always oppose the motion. So it is negative 10, is no longer plus, it's negative 10. Now we are replacing, well, in place of the variables, we're putting in the values of 1. So now it is 10 is equals to, in place of m, place 5, because now we are working on our 5 kg block. So it will be 5 is mass 5 kg. So then in place of a, acceleration, I said, because of that term, light inextensible string, that statement, that line, light inextensible string, that thing, you know what I mean, that description, it means same acceleration, same tension. Yes, the acceleration you find on the other block is the same as the acceleration you're going to find on the other block. So now our acceleration, it was given, which means it is 2 also here. Acceleration is 2, because on our 2 kg block value, when we calculate the tension, we said the acceleration is 2, ne? And now on our 5 kg block, it is also 2. So okay, it will be f cos 20, and then you'll add, it will say in your calculator minus 23.60 minus 10. In your calculator, you write as I say, minus 23.60 minus 10. Don't say 23.60 minus 10. Say minus 23.60 minus 10. And then it will give you the answer. And it will come as negative. And then you'll say, I get it? We're still here. So here value is 5 multiplied by 2 is 10, eh? You see, okay, it is already done here. Okay, it is 10. 5 multiplied by 2 is 10. So then negative 23.60, it is now positive because it is over the equation sign. It has jumped the equation sign. It means now it changes the sign. It is no longer negative, it is now positive. It is transposed from the other side to the other side. Even the negative 10, the frictional force, will also be positive 10 because it is transposed from the other side to the other side. It is no longer a negative 10, it is now a positive 10. So it is, so now we're left with f cos 20 now. It is f cos 20 which is equals to, you'll plus 10 plus 23,60 plus 10, and then we'll have 43 comma, it is 43,6, something like that. Yeah, 43,6. So then on your f cos 20, you'll only divide by cos 20 and leave fa, because this is our force applied. You'll only leave cos 20, you only leave fa and divide by cos 20 both sides, and then here they will cancel one another, and then here it will be 43,6 divided by cos 20, and then your force applied is 46,40 newtons, and then you are done. So let's go to our, I don't know, is this our last question? Yeah, this is our last question on this matter. So now we are required to calculate the coefficient of kinetic frictional force on 5 kg block. The coefficient of kinetic frictional force on 5 kg block. The coefficient, yes, the coefficient of kinetic frictional force on 5 kg block. So don't forget, when you want to calculate the coefficient of kinetic or what force, use this kinetic frictional force formula, which is Fk is equals to coefficient of kinetic frictional force times the newtons. Now you know what I mean. So as I've said, now we have the newtons. You see that you now have the newtons. We now have the newtons now. So it means now we'll also look at the forces acting on our vertical direction, on our y direction. Now we are going to consider those forces because we have now the new the normal force. So okay. So now, okay, we're working on our 5 kg block now, and don't forget, this is the formula that we're going to use when you deal with the kinetic friction, when you deal with the frictional forces. This is the formula that you use. It's Fk, frictional kinetic force, which is equal to the coefficient of kinetic frictional force multiplied by the normal force. All right, so then our normal force is on our y direction, don't forget that, but our Fk is on our x direction. So now I think we know the kinetic frictional force acting on our 5 kg block, but we don't know the normal force. Yes, okay, let's see. The kinetic frictional force acting on our 5 kg block is 10. Here it is given, but we don't know the normal force. You see, it helps reading the statements. It helps also going back to the statements. Like when you deal with equations, always just go back to the statements to like look for the information, so that it will help you like navigate the questions and help you go much further with these questions. So okay, okay, so we don't have the normal force, but we have frictional force, but we don't have the coefficient of the kinetic frictional force. This guy is the one that we are looking for, but we don't know him as well. We don't know the value of him, and we also don't know the value of our normal force. So okay, here's the thing. When you deal with the vertical forces now, okay, look at this thing. The force that is being applied, it has the component that is acting on our y direction. Okay, and look at this thing. The direction it is going to the right. It is not going, the system is not going up or maybe down. It is going to the right. So which means it can also go to the left, because we also have the forces that are opposing the motion. So here it means, okay, on our y direction, okay, I get it, on our horizontal motion, on our horizontal direction, we're given acceleration which was 2 meters per square second. So then on our y direction, we don't have the acceleration. The acceleration will always be zero. The acceleration will always be zero. So which means when we use this force F net, which is equal to ma, so our F net now becomes zero because our acceleration is zero now. Let me just say F net y, or on our y direction, F net on our y direction, it becomes zero now. It becomes 0 newtons now. So it means that the sum of all these forces acting on our y direction, they give us what? Zero. When they are added together, the forces that are acting on our y direction, they give us what? Zero when you add them. And don't forget that the directions will not be the same, because our normal force is now going upward now, and the Fg is going downward. And don't forget, we have the component y force from our force applied. We also include the components. Because we are working with the forces that follow the rule, the principle, either perpendicular to the surface or parallel to the surface. We are working only with those forces that are acting on our perpendicular or parallel principle. You know what I mean? So here we have normal force Fg, and don't forget the component Fya. You know what I mean? So okay, let's go. And don't forget that the acceleration is zero. You know what I mean? So it means when we come here, you're still going to use that. I didn't write this before, but then let me write it to show you. Our F net now is equal to 0. So again, now it is 0. It is no longer ma. It is 0 because our acceleration is 0. So m multiplied by 0 is 0. So we will be left with F net is equal to 0. So as our direction is going upward, you know what I mean? It's going upward, so we'll take the direction going upward as positive. So every force going upward will be positive. It will be added, but all the forces that are acting opposite to our direction, they will be negative. So okay, let's go. So don't forget, okay, our F net is acting upward, is positive, and our Fya is acting upward, is positive. So I just transposed Fg to the other side, so that it becomes positive. So but if we place it here, it was going to be negative Fg, then it's equal to 0. But then I've rushed the things, and then I just transposed Fg to the other side, and now it's positive. But it is basically like this. F net, okay, the normal force is positive, plus the Fya is positive. So then it was going to be negative Fg, because it is going downward. It is equal to 0 or 1. That's the thing. So okay, it is going to be like that or 1. So then we're left with normal force and Fya, and then we transpose Fg to the other side, and then it changes a sign, and then it becomes a positive sign. So we're left with Fn now plus Fya, which is equal to Fg now. So okay, we have Fn plus, and don't forget, we need to find the formula of Fya, and I've done that before. Don't forget that of Fya. Yes, here it is. I've done that before of Fya, which is equal to Fa sine 20, and now we have Fa. Don't forget, we have Fa. We have found Fa. So then now it will be Fn plus, in place of Fya, we put that formula FA sin 20 degrees, which is equals to, then don't forget that FG, it has its own formula, which is mg. The m, mass of an object, and the force of gravity, which is 9.8 meters per square second. So then Fn is equals to mg, and then we transpose, we take FA sin 20 to the other side, and then it will become negative FA sin 20 degrees. So which is equals to, so then in place of m we put 5, in place of g we put 9.8 meters per square second. This one doesn't change, you have to know it by the head. So then minus. I get we transposed FA sin 20 to the other side, so now it's no longer positive, it is negative. So then in place of FA is the force applied. We have the force applied, don't forget we calculated him. 46,40 is 46,40. In place of FA we place 46,40 sine what? Sine 20, and then you find your answer. And then it's char. We were looking for our normal force. We're looking for the normal force. Okay, let me punch in the calculator and find the value. And then because I did not complete this one, but then yeah, I was tired. But then okay, let's go. It's 5 multiplied by 9.8. 5 multiplied by 9.8 minus 46,40 sine 20, which is 6, hey, I don't even know if this is the right one because I'm using this calculator. Yes, this calculator, but then it is giving me, okay, so those that have the right calculators, just I don't trust this phone, guys. I don't trust this phone. It's, hey, so okay, we found 6,64. Let's just say 6,64. Let's round it off. 6,64 newtons. Okay, what? Why is it so small though? Like normal force. Maybe because there's no acceleration there. Yeah, okay, 6,64 ne. But sometimes like you don't have to like round it like right away before the final answer, so that you don't get, yeah, you don't have to like don't round it off before you get your final answer. So on your final answer, that's where you can round off things. So when you can round off your things. But then now we have 6,63 newtons ne. Is it 639? 6,639 newtons. Okay, so then I get off looking for, they say, the coefficient ne, and we're using this formula. We're using this formula, which is okay. So then don't forget FK, already have him on our statements. It said 10 or 1 newtons. So then we don't know the coefficient, but we know the normal force now, which is 6,639 newtons, and then divide both sides by 6,639 newtons. 639 newtons, and then you cancel each other, those ones, and then you're left with this one, which is equals to, and then 10 divided by our answer. And then 10 divided by 6,639 is 1,50. Yeah, 1,51. Let's just say 1,51. As 1,51. This one, it doesn't have an SI units because we're dividing a newton by a Newton. So the Newtons, they cancel one another. So because it's Fk, it's a frictional force which is a Newton, and a normal force which is a Newton, so they cancel one another. So then we don't have the SI units for the coefficients. It is only a magnitude, only a size, only a value. So okay, yeah, I think we are done with this one now. Let's go to the next one, guys. Let's go.